Hey everyone, welcome back to the next video which is about LLM use cases. The real world use cases of large language models are daunting and challenging. This is not about just playing around some algorithms, but rather building some real world applications. In the last video, we talked about large language models and an introduction to generative AI models. That means where you are able to generate new set of content given a model, right? And also you are training with lots of data so that these models understand the data and the pattern in the human spoken languages. For example, natural language which we talk, humans talk in English or Spanish or whatever language, and we are processing that data to generate new set of text, images, or any other type of modalities. I'll talk about modalities and different type of models that are available. The models have been trained on large amount of data, as I said, and that's why they can understand and interpret human languages with a level of accuracy, and that is quite amazing. So with the help of artificial intelligence and machine learning, these models can understand, analyze, and create a language that sounds like it was written by a person on a scale that was impossible before. And this was opened up new possibilities in many fields such as content generation, content creation, data analysis, programming, code generation, and more. So application of generative nature. When I say that generative, the if you look at this word generative, right, which is basically generate, and we have seen this word couple of times, and like in previous slide as well as now. Generate is, let's say I haven't given image of a cat and want to generate. Let's say this is a black color cat. I want to generate a red color cat, yellow color cat, which doesn't exist. But the models can do that. The models can do that based on the instructions. So generative AI models like GANs, which is basically a adversarial network that aims to learn data distribution P of X, allowing realistic simple generation. So GANs employ adversarial network in zero sum game for training. Will not need to go into deep dive into zero sum game and GAN algorithm and etc, because I would say this is kind of an history or background about the advance and also the improvements over the generative models. So GAN was one of the pioneer in creating these generative AI models. GAN was example of GAN models like which were data augmentation, super resolution. Then we have inpainting, denoising, image translation, collection style transfer, object transfiguration, image colorization. If you look at this particular image here, which is denoising, so I have some noises here which getting denoised using generative AI models. What primarily it is doing, it has a set of image and is trying to generate a new set of image which is maybe a more improvised version of the previous image, isn't it? But that definitely needs a generation capability, and it is not just about predicting new set of pixels. And then there is something called style transfer. You want to transfer this style to a Mona Lisa portrait, and that it becomes just similar to this style. That's amazing. Style transfer, I think I have seen around 2019 or 20, and it was like an amazing technology or model that has been now evolved over the time. And again, that comes under the model category of GANs. Similarly, we have object transfiguration. Let's say I want a horse's figure into a zebra's pattern. So that's amazing. This kind of stuff we can do in application using generative AI or GAN models, right? And then we have super resolution. So if I have a very less resolution image and I want to increase the image of that resolution of that image, and which is a high resolution image. So these are all example of generative models. We are not yet talking about generative AI models, but this is GAN and more like previous versions of these models were from where it has got evolved, and there are a lot more things that we will talk about when we go into the later modules. But LLMs have been using the changing data, a lot of patterns, and it is learning from that, which is opened up new possibilities in many fields, in the content generation and image generation, text generation field. So what are the importance and usefulness of these models? So generative AI models hold immense significance across various fields, right? For example, data generation. I wanted to generate new set of content. I want to write a blog, right? So I want to create a very unique blog, and I can generate data, which is basically an example of data generation. Anomaly detection. I wanted to find out if there is a car service happening, is there any fault, and how many faults are there. Anomaly detection. Image and content generation. I can have a cat's image, and using that cat's image I want to generate let's say a dog's image, right? So that can be a possibility that is possible using generative AI. Similarly, data privacy. Data privacy. I wanted to remove all the PII information such as name, phone number from a given data set. I can use generative AI. Data privacy, domain translation, semi supervised learning, reinforcement learning, medical imaging. All these are importance that I would say the generative models are continue to evolve, playing a crucial role in addressing diverse challenges in machine learning and the artificial intelligence. So let's first look at one of the examples of these kind of use cases that has been developed by one of the pioneering company called OpenAI. OpenAI has been so popular only because they have published ChatGPT, but it's not the first model that they have introduced, right? As we saw in the previous diagram, a map from 2019, after GPT-2, they have released GPT-3, which they actually took the open source version of GPT-3, which is GPT-2, and developed a new model, which is nothing but GPT-3 version or GPT 3.5 version, the chat model. So OpenAI's text generation models, often called generative pre-trained transformers or large language models, have been trained to understand natural language code and images. So with release of GPT-4 Turbo, you can now build systems that also process and understand images. So it's not just text but images, and we can call one part of it as a model. So if we understand text, we can say it is only textual model, but if it understand both text and images, we can say that model is an multimodal model. That means it can understand text as well as images. So now you can feed in a cat's image and you can ask it to describe about this cat, right? I'm sorry about the images, but I think this is for learning. So with the release of GPT-4 Turbo, we have this exploring GPT-4 Turbo with image inputs and GPT-4 Turbo. We'll look into this in practical understanding later on, but this is just to give you guys an understanding about the different type of model that only OpenAI has released in the section of text generation models. So what are the use cases of text generation? Conversational agents, content creation. Conversational agents are like, I can have different set of agents or bots that they can actually interact with each other and give me an output, right? This output is driven by these agents. You can have a content creation like blog generation or writing an article. Language translation. Let's say I want to translate from Japanese to Chinese, right? I can use language translation model. Code generation. So I want to ask the LLM to write a Python code, right? So it can generate the code from the given context, and similarly it can generate poetry or literature. It can do a summarization. I can give a set of documents and I asked it to summarize it pretty well, and then question answering, right? So I want to do a chat conversation, or I wanted to ask questions like what is the best game in US, right? For example. Similarly, personalization. I wanted to create some personalized version of the contents, fake news detection, gaming character and story development, speech transcription. All of these are some of the examples that we can think about as in text generation use cases. So LLMs can power question answering system in many areas such as customer service, education, healthcare. For example, a chatbot for customer service could use LLMs to understand customer questions and answer them promptly and correctly. This is one of the things that we can think about in the area of question answering system. There could be language translations, right? So LLMs can help improve the accuracy and speed of language translation by understanding the subtitles of different languages and doing natural translation. That's an amazing use case. So this could help businesses in more than one country or people who need to talk to people who speak other languages. All right, so there could be a lot more use cases that we can keep talking about, but I think this gives you a very brief understanding about different use cases that LLMs can be used for. Building NLP applications. So using OpenAI's text generation models, you can build applications to draft documents, write computer code, answer questions about knowledge base, analyze text, give software a natural language interface, um, tutor range of subjects, translate languages, simulate characters for games. A lot of use cases that is coming on using OpenAI API, right? So I would like to give you one example, like for example, market research for competitor analysis, right? So when making a content strategy or launching a new product, it is essential to research the market, right? The information gathered often determines what is written about and how it is told. So language models like LLMs can help get and look at the correct data for market research and the competitor analysis. So these are some of the areas or categories where we can talk more and develop different use cases, right? So the ability of language models like LLMs to develop new ideas has to be powered by some of these serverless deployments. For example, OpenAI has deployed these models like GPT-4 Turbo, GPT-4, GPT 3.5 Turbo, which is a set of model that improve GPT 3.5 understanding. Similarly, DALI, a model that generate and edit images given a natural language prompt. TTS, which is a set of models that can convert text into natural sounding spoken audios. Whisper, which is a model that can convert audio into text, which is a speech to text model, I would say. And embedding models, like a set of models that can convert a text to a vector or an embedding, whatever you say, vector, right? So like say form of floating representation, float representations. Moderation, so a fine-tuned model that can detect whether a text may be sensitive or unsafe. GPT based, so a set of models without instruction following that can understand as well as generate natural language or code. And then we have some deprecated models, we don't need to talk about them. So what we do with OpenAI, we can send a request containing inputs, prompt, exemplars and your API key, and then receive a response containing the model. So basically you are having these OpenAI models deployed in their instance, and you are sending a prompt to it, and it is giving you the response, right? That's the goal. So we access the latest OpenAI models like GPT-4, GPT 3.5 Turbo through the chat completion API endpoints. So they have deployed this as a service, and you can use this as a SaaS platform. So you can use these models as an API access key, and you can make a call to those models, send a prompt, and get a response from those models. Here is an example that OpenAI chat completion API being used here, right? So an example chat completion API, that call looks like the following. So you are importing the required libraries from OpenAI, importing OpenAI, and then you are creating an instance of that OpenAI class, and then You are basically building the response API client.chat.completion create, providing the model name which is GPT 3.5 Turbo, and you are providing the messages. So here I have a set of roles. I have a system role, I have a user, I have an assistant, and the user. I'll talk about system, what is the play of system, what is play of user, when we talk about details in prompt engineering section. But for now, just understand that this is kind of an instruction, high level context that is setting the model to understand, okay, you are an helpful assistant, you are, maybe I can say you are an helpful yoga teacher, or you can say you are an helpful soccer player, right? So something like this, which actually sets the context, so the model knows that you are going to talk about yoga only, or going to talk about soccer only, right? So those kind of roles you can define as a context before, and then you can ask questions like, who won the World Series 2020? So the assistant says the Los Angeles Dodgers, who won the World Series in 2020. Similarly, where was it played? This is question from user, and it's going to give the next set of answers and next set of answers and so on. So you can actually look into this, a deep dive into it, and even if you wanted to look more around, you can go to API reference documentation for Chat API, and you would get a better understanding of what is OpenAI chat completion. And there are much more than this. There are many more APIs that are built by OpenAI and available for the use. All right, so in the end, the ability of language models, I would say, is to develop new ideas that has been given business and all the fields a whole new set of options. So LLMs are used in several ways to help businesses, right? And this include content creation and optimization, market research and competitor analysis, question answering generation, code generation, and so on. So LLMs are changing how we use technology and business because they can understand and create content that sounds like some human wrote it. That's amazing, isn't it? So let's look into the next session. Thank you so much for listening.